Alright guys, so in general, you see this rule a few times throughout those handouts I gave out. Log base b of a equals c. I can rewrite that as b to the c equals a. Because the answer to log is always the power you need on the base to become the argument. Yeah. So how do I rewrite this? It's currently in exponential form. How do I make it into log form? What's the base? 3. What's the power? 2. And then the argument must become the inside. The output of one is the input of the other because they're inverse functions. Hopefully some of you guys, I know people were in lab, so I know some of you guys were working on this in lab. There's a lab? All right.
Did you pass that out in our lab?
Yes.
I didn't get it.
Okay. Sorry. So this one here? Yeah, I said to keep it, and you didn't have to turn it in because this side had all these notes. Okay. Huh? No, I didn't bring extras. I brought a few extras, but all gone. So you can always email me if you didn't get a copy. I can email it to you. Okay, I like it. I know I gave it to all my labs because otherwise, what would we have done? So on this guy, try to rewrite this guy if you haven't already. So again, just so if you don't realize, you have this sheet with all these different rules and stuff, and some examples and stuff. Well, the other side is what I'm doing right now. So this guy, log base, z, this base is z. Yeah, the output becomes the input, and the answer to log is always the power. I love it. That's the harder way to do it. This is the easier way to do it, because all you do here is you say base to the power equals the argument. I love it. Cool. And when it's all numbers, you can actually make sure it's true. That's always nice. This one, same idea, just can't check it, but oh well. M to the A, W, mall. Cool. So these, I talked about these, I think, in the lab. Because don't write 16 to any power. There's no 16s. There's x fours. There's 2x more fours. When you multiply like bases, you do what with the powers? Add them. So it'll be 4 to the 3x. So the properties of powers don't change just because my powers are gross. Variables, fractions, whatever. Right? The property, if I'm multiplying like bases, I add them, no matter what they are. So here, when I divide, what do I do with the powers? Subtract. This is not 1 to something. You don't cancel the 3's. I really want you to understand. How many 3's there are on the bottom? There are twice as many on the top. Right? There's M3's down here. There's 2 M3's up here. You can't kill all of them then. Right? In fact, if you think about it that way, if there's 2 M3's up top, M3's down below, how many are left after I kill some of them? No.
3 power M2.
Oh, that's right, there's a 3 up there. 3m up there, m down there. What do you do with the powers? Subtract. What's 3m minus m? 2m. I like it. So If there were fractions, you'd still subtract them, you just have to get LCD if you didn't already have it. We've seen that before. What about this guy? What is the question you're asking yourself when you see this? You're asking, why do I have to know this? You're asking what power does 4 need on it to become? Or you're saying how many 4s does it take to multiply to be 64? How many legs does it take to be the center? Teacher rule. So this will take 3. So that's 3. Because 4 cubed is 64. Right? In fact, let me see if I can get you. What's the cube root of 64? 4. There's a connection here, but they're not the same, right? Here I know the base, I don't know the power. Here I know the power, I don't know the base. So what do I cube to make 64? 4. What do I raise 4 to make 64? The third power. There's a connection there. But here the power is not known, here the base is not known at first. Okay, maybe. So of course this guy, we've seen this guy a few times. What's wrong with the person that says 9? What's the person that says 9 thinking? They say it's equal to 9? That's not right, correct? But what are they thinking? 3 times 9 is 20, or 9 3s add to be 27, but that's not the question. What does it take to multiply? How many 3s to multiply to 27? 3. I like it. And this guy, hopefully you understand, to make it flip, it's got to be what kind of power? Negative. And to make it 25, 2. So you kind of construct it. Negative to flip it, 2 to make it become 25. You kind of take the flip out of the way and say that would be 2 if it was log base 5 of 25, and then it's negative 2, so it flips it. Kind of deconstruct what's in there. That's one way to do it. What's another way to do this problem if you don't like doing it that way? You can say that the answer, I don't know the answer. See, this is really funny. Some of you guys like to do it this way. And if you don't even like it, you still can see how it's useful. This is freaking algebra. I don't know what the answer is, so let me call it x. And then I can do shit with it because I gave it a name. So 5 to the x equals 1 over 25. And then you focus yourself on making this in terms of 5, and then x has to be negative 2, what we got up here. It's really the same exact thing, it's just it looks a little more in your face of what's happening. So either way you want to do it is fine. We've done something like this, and we've certainly done something like this. All right. Now this is an example where the base isn't flipped, but the answer is. So I have to raise it to a negative power to flip it. Now here's an example of a base that's flipped, but the answer ain't. I still have to. Yeah, some of you guys enjoy my bad grammar. So I still have to flip 1/2. Is that, you guys see what I'm saying? I still have to flip it, because if it was a 2, what would the answer be? Log base 2 of 8. How many 2s does it take to multiply the 8? 3. But here the answer is not 3, because the very first thing I have to do to 1/2 to make it become 2 is flip it. So again, if you wanted to, you can write 1/2 to the x equals 8. 2 to the negative x equals 2 cubed. Negative x is 3, so x is negative 3. You can still solve it that way. It's not a damn thing wrong with that. That's some good algebra. What the hell? And that's the class you're in. So obviously I'll love that. What do you guys, try to do this one. Let's see if you guys remember that. If you haven't done that yet. See, when people do this, subtraction cannot become division. So this is something minus something becomes something divided by something. That makes 0 sense. And then somebody comes back at me and says, well, that's what the property says. You know it ain't. The difference of two logs is the log of what? I subtract powers when I was dividing. So this is a power, this is a power. Why am I subtracting them? I must have been dividing the things. So it's rules of exponents. Same rules. Why? Because logs are powers. So we get log base 3 of 3, which is what? Because 1, 3 makes 3. So of course this one, if I'm subtracting leads back to division, adding leads back to... When do I add powers? When I was doing what? Multiply. Log base 6 of 36. 2. Okay. Part of my job is ignoring those of you that look like you want to argue. There's several of you doing that. I love how very few laugh at that. You're all like, you need to watch out. All right. If you have questions, please, dear God, ask them. We can do other examples of these. You have handouts that show you these properties. You have homework that you should be doing that a lot of you haven't. There's a lot of people that haven't done any Chapter 12 homework. I don't get that. All labs have had a quiz. So if your plan is to not do the homework and then avoid the lab so you don't have to do the quiz, well, that's stupid shit. Right? I don't quite understand. Everybody knows you can work on homework at home, right? Or on a computer, wherever there's a computer. You don't just have to do a lab. Everybody, I can't remember if I said that earlier, but I got it. Okay. Sorry. All right. So why is this one not difficult at all? It's almost too easy to get, to be honest, at first. Yeah, it gives you the answer. What do I raise m to get m to the negative 8? I raise it to the freaking negative 8. Another way to look at it is log base m and m to a power are inverses that kill each other, so the answer is negative 8. Just like a cube root and a cube would cancel each other. Okay, cool. Love it. Sure. Now these we've been doing for a while. We actually got into the more complicated equations here recently. Why is this one not as complicated as what we were doing? I don't have to bring logs in. In fact, if I give you this equation, I really don't want to see any logs taken. It would make it so much more complicated than it has to be. Why is this one easier? Because what can I do with 8 and 4? They're both based on 2. 8 is 2 to the third. Here's a little something. People don't quite... If you notice, all I did was rewrite 8 in a different form. So, of course, the 2 to the x is still there. People sometimes are mystified. How did I do that? Well, because 8 is this. So I can just write 8 in that way. It's another name for 8. And, of course, 4 is 2 squared. And I still have the... And here's another place where people make a mistake. What do I do with the powers when I raise something with a power to a power? Multiply. So this will be 3x has to equal this power, 2x plus 8. You got to distribute that too, of course. You multiply 2 times the whole x plus 4. And then if you solve it, you get x is 8. Oh, there you are. I want to show you guys something. I'll probably say this again in lab, but watch this. Watch this. Watch this. 8. All right, now. I can store that, store it. This little stow button, store it. I can store that in x. Store it in x. Enter. Now just watch. This kicks so much ass. So if I do 8 to the x, okay, I get that. And it's got to be the same thing as 4 to the x plus 4. See how I just write it exactly the way it is? I didn't have to put those parentheses in, I was just being extra careful. All right, there you go. So I checked the equation, right? I plugged the value back in, and I made sure that it worked. You don't have to do the whole store thing, to be honest, but it's kind of nice to be able to just type it in exactly the way it looks in the equation. Holy shit, and they're equal. That means it's true. Yeah. Somebody guy's perked up about that. Okay. We're pushing buttons, yay. Stop. All right, so you guys try this one if you haven't done this one yet. It's exactly the same idea as this. So try that one. So how do you do this one? 27 is 2 to the third. And then 81 is 2 to the fourth. So the base is the same, so now I can just focus on the exponents. So I get 12x minus 3 has to be the same thing as 8x plus 20. So subtract those, add those, 23 over 4. And you can do the same thing I did earlier with the store thing to check it. This one you might be able to do on site. I mean, what's this really asking you? It takes 3 whats to make 8. Yeah, it takes 3 2's to make 8 when you multiply, right? So the answer is 2. If I rewrote this, what would it look like? Yeah, x to the third equals 8. And then just the same in question, right? What do you cube to get 8? I like it. Now this one, it's all about rewriting it, right? How do I rewrite this?
7 or negative.
Yeah, 7 to the negative 2. Sweet. So if I just do this, I'm done. Yeah, 7 squared is 49, and you flip it. I like it. Okay, so here, take a minute and try to do this. And back here are those rules. Oh, yeah. Yeah, there she is. There it is. Cool. If you need a copy of the handout from yesterday's lecture, it's up here. What's it look like? It's got 12.5 on the top. All right, so what's the first thing I got to do on this one? Yes, cool. So I don't have any property about 2 logs plus 3 logs. There's no property about that at all. But there is a property about log plus log. So what's in my way is these stupid coefficients. So I just bring them back to where they were. All right? Somebody must have taken them down, so I just put them back up, because that's the property logs have, is that that goes back up, that goes back up, that A goes back up. And now I can use that addition and subtraction property. Be log base 6. Let me see if I can do this all at once. Well, I'm adding, so what was I doing here? Multiplying. And I'm subtracting, so what was I doing with this guy? Dividing. A. Poor little A's. Their little stubby 9s. Oh. Okay. So again, if you didn't get one of these, you can just email me for it. On this reverse side, it does have some notes on some stuff we talked about, just kind of all in one place. Solving, rewriting, and then the log rules. Okay. So, yesterday, we got through these 3. This last one we did. What do you guys think we do on number 4? I mean, this would be so easy if only that one log wasn't there. If that one log wasn't there, what's the base on that guy? 10. So I can just do 10 to the first. I'd be done. That'd be kick-ass awesome, but that stupid other log is there. Shit. So I know what to do when it's log of mess equals number. I know what to do then. So is there a way to rewrite this side so it is a single log? Yeah, so I'm adding 2 logs. So I must have been doing what with these guys? Yeah, x squared minus 9x. I must have been multiplying these 2, right? The sum of the logs is the log of the product. Still equals 1. But now I've rewritten it so it looks more like that last one we did. It's going to be just as straightforward at first. So now I rewrite this. Of course, we just said the base is 10. 10 to the first is that. And the big thing is, just because we get into a new section doesn't mean nothing before that section comes into play. This is old news. So now you just forget where you came from. How do I solve this? I see an x squared, oh shit. Why is square rooting not going to do me a damn bit of good? Can I square root across a minus? Just to see what it would look like. Oh shit. Alright, let's not do it. I can't do anything with this side. If it was x squared equals 10, then square rooting would make sense because there's only one term with an x in it. Then that makes sense. Here there's 2, I can't do anything with the square root. So again, if that x squared term wasn't there, I could just divide by negative 9 and be done with it, but the x squared term is there, so I get it equal to 0. Subtract 10. So that idea of getting equal to 0 and trying to factor, and if you can't factor, you do quadratic formula, that idea always applies. It doesn't matter where the thing started. It started with a bunch of logs in it. Alright, we got rid of the logs. Threw them out, made a little house out of them, whatever. Now you just deal with what it is. And how do I factor this stuff? Yeah, the big one's got to be minus. And then you get x is 10. Now, logarithms have a big problem. If you remember, the logarithms look like this. There's an asymptote here. That's that asymptote that is for like an exponential, because the logarithm is just the inverse of an exponential. What the shit does this mean? Well, I can't do log of 0 or negative. I cannot take the log of 0. So what would a log base 3 of 0 be? That would be the power that you need to raise 3 to make 0. Think about that for a second. What's 3 to the 0? So that ain't the answer. What's 3 to the negative trillion? 1 over 3 to the trillion. That's not 0. That ain't the answer. Oh shit. There's no answer. Undefined. Okay? And then negatives are even worse. I mean, you don't even have something coming close to them. They're just over there in bad territory. So, what does that mean for our problem? Well, I got to double check my answers and make sure that neither one of them makes the inside negative. What does that sound like? It sounds like what we had to do with radical equations. The square roots can't handle negatives. Logarithms can't handle negatives or 0. So let's see, 10. Is 10 cool? 10 minus 9 is 1, and 10 is 10. They're both positive. That's cool, and I can even check it. Log of 1 is 0, and log of 10 is 1. So the answer is 1. Yay! What about negative 1? Negative 1 minus... Oh, shit. Alright, so I better cross that out and circle the 10. Oh, no. Alright. You guys understand? It's just... So there are a lot of similarities between logarithms and radicals. There's a lot of similarities. They're not the same thing. But the same way that square roots have issues with their domain, logarithms have issues with their domain. Let's talk about that for a second. This is more case. I joked this person, whoever left this number, but I owe them a lot. Okay. So now watch this. Let me see if you guys remember this. How would I find this guy's domain? Oh, shit. On the last test. Well, it's got to be true about the inside. That's how I do it. I say, in English, I say the number inside has got to be at least 0, and then I write what I just said in Spanish. I love that. In my head, I was thinking other language, and then I chose Spanish. But let's just use math, because I don't really know a lot of Spanish. So how do I solve this? Add 7 to that. If you don't know that, then I don't know what to do for you. All right, now watch. what if the function was instead log of x minus 7? It's not exactly the same idea. Can the inside be 0? What did we just say? No, because remember, what's a log look like? It looks like, oh, there's an asymptote here at 0. It never gets to 0. Why does that make sense? Because log is the inverse of a function that never gets to 0 on the x-axis. So the inverse never gets to 0 on the y-axis. I mean, it's, right? So that means that x equals 0 cannot be used. I cannot have a 0 or a negative inside, which means the inside has to be strictly greater than 0. So then x must be greater than 7. So if I plug a 7 in here, it's included because 7 minus 7 is 0. Square root of 0 is 0. Because 0 times 0 is 0. Try to plug a 7 in here, log of 0 is undefined. Oh shit, so that's why it's not equal to 7, because I'm not allowed to include it, because it makes it undefined. Okay, I like it. So again, all that is just to say, check your answers on these log equations. The inside can't be 0 or negative. You got to throw that out if it is. Don't just not write -1, by the way. Because then I'm like, why didn't you even get that answer to check? Cross it out and circle the other one. It doesn't work. Yes?
Will there ever be a time when you do the equations, the both answers make it a 0 or negative?
Yeah, sure. You could have, one answer, two answers, no answers. You can have more than two answers even.
So that makes sense undefined then?
No, there would just be no solution. If all the possible solutions don't work, then there's no solution. Yeah. So what's kind of wrong with this guy? To be able to, I want to try to do the same thing I did here because there's too many freaking logs running around. I want to kind of put them together. So what's wrong with them currently? What's wrong with the logarithms? Why was this one easy to put together? Because they were both together. So now I can just put them together. What's wrong with the logs here? They are apart. Aw. Let's bring them logs together. How do I bring them logs together? Subtract this one. Maybe the 1 by itself, right? So go ahead, do that. Keep going. Go as far as you can. It's the exact same idea as number 4. You just use a different property here related to the subtraction you're about to do.
Hey,
Need that?
okay, yeah. Thank you.
Sure. So here we use the property. When I add logs, it's the log of the product. Here I'm subtracting logs, so that's the log of the quotient or division. So I'm subtracting power, so I must have been dividing. The property is way too easy to remember. That can't be true, Jeff. Math is harder than that. And do you notice, I mean, if I get there to be a single logarithm in the equation, I can always do the same thing. I can rewrite it, base to power equals inside. So this will be 2 to the first is 2 equals. Now I'm wondering if anybody got there and was like, do I guess? No, never guess. Guess and check is bullshit for this class. This is not intermediate guess and check. That was fun. So, how do I solve this? What's the main problem? What's the worst thing about this little equation? Stupid fraction. Well, how do I kill a fraction? Yeah, multiply by x minus 1. So then these cancel here. This is going to be 2x minus 2 equals x plus 2. Subtract x, add 2, you get x is 4. So you get one possible answer. Does it work? So when I throw a 4 in, this is 6 inside, which is good. And this is 3 inside, which is good. And if you want to check it, you can actually, log base 4 is 6 minus log base 4. Log base 2 of 6 minus log base 2 of 3 is log base 2 of 2, which is 1. So it does work. Or you can use your calculator. Change your base. Alright, try this last one. Same idea. So how do you write this? Log base 4 of
X divided by X minus
x over x minus 15. And now I got a single logarithm.
4.
So now I can do
4 power 2.
4 squared. So you get 16. Multiply by the x minus 15. I don't feel like multiplying these, so I'm not going to. Aha. Now you guys can multiply those, right? I mean, so could I, but I don't feel like. So subtract x, 15x, add 16 times 15, divide by 15, the freaking 15s cancel. I didn't have to multiply this stupid shit. Yay! It's kind of a neat trick. When you're solving, you just don't multiply and then see if you had to later. Stuff might cancel. But if you multiply, you're not wrong, you're fine. Does it work, 16? Does it make anybody freak out? It's positive, and 16 minus 15 is positive, so it's all good. Okay, I like it. The last section, let me leave this up here for a second. The last section in chapter 12 deals with real life applications of exponential stuff. So, like exponential growth, radioactive decay, other things that are modeled by exponential growth, like the number of people who are using social media. You don't have to go that far when there were very few. Back in the early days of MySpace. Even before that, we had some really freaky things back in the 90s when you had to start a page to load and you went to cook some dinner and then you came back and you're like, it's halfway there, okay. My dinner's done. All right, it's done, yeah. Anyway, so the last section, 12.7. I'll have a handout tomorrow, hopefully. It's going to be population growth, exponential decay, like radioactivity and stuff, and other things that are modeled with exponential or logarithmic functions. And nifty, so this was in our future. So there is whoever the lab is after this, there's that quiz, and there's another quiz, of course, Wednesday and Thursday. Those quizzes will cover exponentials and logarithms. And then, of course, the test, just make sure everybody knows, the test has been moved to the 15th. You notice that my math lab due date's 15th. We had to move that last test forward, so I decided to do that with this next test. Okay, that's enough. I'll see some of you guys in the lab.
Where's the lab?
Yesterday I sent an email about Luna being returned
If you can come to the lab right now, you can take it then. Otherwise, your test grade will count as your quiz grade. Yeah.